Hello everyone. How are you all doing? Hi everyone. Hello everyone. Am I audible and visible to all of you properly? Let me know. Let me just check if the live has started. I did not have to check. Okay. 1 second. Yeah, am I audible and visible everyone? Let me know. Am I audible and visible properly? Today we are going to see a very important chapter of your class 10th, that is your physics chapter, and that is bacha light. How many of you have studied it, have understood it, have liked it, have hated it? What's the response till now? I guess all of you must have completed this chapter in your classes or schools, right? And these are almost the mid of summer vacation, so we all may be just taking it light, but this is the first chapter, so you probably would have done it. You probably would have been thinking the ray diagrams are so hard, the numericals are so hard, and the sign conventions, there are just too much things, right? Isn't it? Okay. Yeah, that's usually the first impression of people whenever they open this chapter light, right? But it's a very interesting chapter, that I can guarantee you. Okay, and once you get the gist of it, once you get a good grip of this chapter becomes, like we say, halwa. This chapter becomes so easy, smooth like butter. Okay, so you have to just stay with me, come to the live sessions, and you'll see how much easy this chapter actually is. Okay, give me a thumbs up, all of you who have joined. Give me a thumbs up if we can start finally this live session. Okay, we will first look at some of the very important sign conventions that you guys think are very hard, right? That you guys are afraid of and you run from it. So we will start with that, and I just saw that we hit 13k mark, so congratulations to all of you with me, right? Okay, Samved, okay, Samved has said okay, so let's just start this first session. Okay, the first session of physics on this channel. And beta, now you have seen light, we have seen what there are, how many kinds of optical instruments we are using. We are using two kinds of optical instruments, right? First is what? First is a mirror, and we are using lenses, right? We are like literally just playing around these, right? The image formation, the nature of image, the size of image, right? Hi Vishal, how are you? How many types of mirrors are there, Vishal? And how many types of lenses are there? You let me know in the chat section, okay? Until then, I'm also telling you, one, we have concave mirror, right? And second, we have concave lenses, convex mirror, and similarly we have concave lens and convex lens as such. Done. Now we know the differences. Concave mirror and convex lens are similar, right? Yes, mirror and lenses, very good. Concave mirror and convex lenses are similar. How these are similar? Two types. Very good, great. Now concave, for now let's just remember, quickly go through it, because we have to do numericals, we have to do questions, all of you have to answer, so quickly revise it. What kind of image is formed, the nature, the size, magnification formula and all that. Okay, so we'll quickly revise that in just 5 minutes, and then we'll move on to our numericals, our MCQs, questions. Okay, NCERT questions, all of the NCERT questions I have done in today's live session. Okay, we'll mostly go through the reflection ones today, and next time we'll go through refraction ones. Okay, Vishal, done. Now bacha, in concave mirror we have 6 cases, right? First to 5 cases are normal ones. 6th bacha is, we call it a stupid case, okay, because it has to go the other way, right? Now in first to 5 cases, the image formed is, it's real and it's inverted and it's of all sizes. All sizes. Understood? Anyone have any doubt? And what is the nature of image in the sixth case? Tell me, what is the nature of image in the sixth case? In the sixth case of concave mirror, what is the nature of image formed? Okay, great. So in sixth case, a real and inverted image will not be forming, right? It will be a virtual and erect image. It will be virtual and erect, and it will be a enlarged image. It will be an enlarged image. Now one more question I have for you guys at this moment is, you tell me the sign of focal length, the virtual, right? Devesh Tripathi Ji. Yes, Devesh Ji. Tripathi Ji is right. It is virtual. Now one more question I have. Devesh, Vishal, all of you. What is the sign of focal length for concave mirror and convex mirror? And similarly for concave and convex lenses, those are exactly the same, but what is the sign? The sign of focal length for concave and convex mirror and lenses. Until then, see, the second mirror we have is convex mirror. Now ma'am, we know that in convex mirror always forms virtual and erect image. Virtual and erect image, but in this case the image is always diminished. It is always diminished. Are you guys understanding this? In this, the image is always diminished. That's the difference between concave mirror and convex mirror, right? Concave mirror and convex mirror, because both of these are forming virtual and erect, but concave is forming enlarged image, convex is forming diminished image. Okay beta? Concave mirror negative, convex mirror positive. Very good, very good. And same for lenses or different? We know that image formation is like inversely connected to mirror and lenses. The focal length, is it negative for convex lens or what? What's that scenario? Is it same for mirror and lenses or is it different? Okay, now look at this very carefully. Convex is also yellow. Okay, now see, concave mirror will be similar to convex lens, so everything will be same. We will have 6 cases. First to 5 cases are normal one. 6th case is again a stupid case. Okay, and then in this we have real and inverted image of all sizes. And in the 6th case we have virtual and erect image that is of diminished. It will be diminished, right? And then convex mirror will be similar to the concave lens. So same, virtual and erect, and it will be always diminished. Oh, here I said diminished, right? Here it won't be diminished, it will be enlarged. My mistake. Okay, it will be enlarged. This whole slide, is it clear? Opposite for lenses, okay? Okay, let's make this very clear. Now beta, for mirror and lenses, the nature of images will be opposite, right? The concave mirror will be similar to convex lens, okay? And convex mirror will be similar to concave lens. But in case of focal length, see, focal length for concave is always negative. Anywhere you see concave, you don't even have to see mirror. Is it a mirror? Is it a lens? Anywhere you see concave, you just quickly write negative focal length. Okay, so for concave mirror as well as concave lens, your focal length will be negative, bacha. Okay, and for convex mirror, anywhere you see convex, the focal length is positive. It is positive, be it a mirror, be it a lens. So convex lens focal length is again positive. Understood everyone? This is something you have to always remember. Okay, Anywhere you see concave, the focal length is negative. Anywhere you see convex, the focal length is positive. How do I remember this? I have a very silly trick. Okay, this x, if you turn it, it will be a plus sign, right? This x, if you rotate it, it will be a plus sign. Correct. So for convex, the focal length is positive. Convex, x of convex, focal length is positive, and x of convex lens, focal length is positive. So that's what you have to remember. Okay. Okay. Great. Now all the doubts are clear, right? So this is the whole slide that you need to remember. If you want, you can have the screenshot. This is all the knowledge you want to have about the image formation. Okay. Now, quickly tell me the formula of mirror formula and lens formula. What's the exact formula for mirror formula and lens formula? So, you write it in the chat section, okay? Now, bacha, mirror formula is simply what? It's a relationship between the focal length, the image distance and the object distance. Okay, so we will have 1 by focal length equals to 1 by image distance, that is V, plus 1 by U, that is your object distance. Done? Okay, then we have lens formula. What's the difference between mirror formula and lens formula? Ma'am, that is very simple. What is this? Just because this, take out this positive sign and make it negative. 1 by F equals to 1 by V minus 1 by U. Understood? Understood, everyone? Okay, give me a thumbs up, send me a heart, whatever you want. Okay, now magnification, right? Magnification is also a big thing. Now magnification for mirrors, it is what? Magnification, okay. Magnification is minus V by U, image distance by object distance with a negative sign, equals to height of image by height of object. And this bacha is for mirror. Right, this is for mirror. Now same for lens, but just not this negative sign, everything else is same. 1 by V plus 1 by U equals to 1 by F. Very good Devesh. So for lens we have plus V by U, height of image by height of object, but this is a lens formula. Understood? Okay. Now I have one very important secret weapon for you, okay, and you have to take the screenshot like really quickly, but because I have made a table of summary of all the sign conventions. Okay, all the sign conventions are there, very important, and if you just cram this table and throughout your board you won't need anything else for light numericals. Okay, ready 1 2 3. Okay, so see, this is the nature and position of image for concave mirror. Remember, concave mirror. So all the 6 cases, at infinity, at focus, beyond C, between C and F, all the object positions, all the image positions, size of the image even is mentioned. Okay, nature of image is mentioned, real and inverted. In the end, we have virtual and direct, and we have sign conventions as well. So we know the left side of the mirror is always negative, so U is always negative. And if the image is real and inverted, that also means the left side, that means the V is again negative. Height of the image is forming below the principal axis, so height is negative. Okay, so all of this is mentioned, and you will see in the 6th stupid case, the image is formed on right side of the mirror, right? So V is positive. Understood? Everyone, give me a thumbs up if this is helpful. Okay. Now, same for we have convex mirror. We just have 2 cases of convex mirror, at infinity, at focus, between any point between P and F behind the mirror. This is highly diminished, virtual and direct always, and it is always diminished, right? And here also U is negative, but image is formed on right hand side of the convex mirror. This is how the image is formed, right? Say here. So V is always positive, and image is formed on the upper side of the principal axis. So height is positive. Done. Next, same for lenses. Okay, you can have this information as well. Same for lenses, but we know in case of lenses, even the real and inverted image is formed on right hand side of the mirror, right? The real and inverted, it is real and inverted, but image is on the right hand side. So V is positive in the first 5 cases, and in the 6th case V is negative. If you see in the case of concave mirror, this is where we lag. Okay, this is where we need to understand. In the first 5th cases V is negative, end case is positive. In here, first 5 cases V is positive, end case is negative. Understand? Diminished, diminished means small. Diminished means small, bacha. Okay. Okay, done. And similarly we have for convex lens. This was convex lens, we have concave lens. Okay, same, all the sign conventions are given here, just go through them. If you don't understand anything, you ask me. Okay. Okay, now let's move on to our first question, that is your very first question of NCERT. Okay, it's an unsolved question. You might not have the answers for it, so I have gotten okay, done. Okay, now first question. Anyone who can explain this is like, I will place you in the top list. Okay, let me know fast. Fast everyone, what's the answer to the question? Define the principal focus of a concave mirror. Yes, click was. Ask your doubt, bacha. Ask your doubt. Okay, everyone, when we talk about principal focus, okay, what's the worst thing that comes into our mind? Ma'am, this is a concave mirror. Okay, if we draw the principal axis, this is pole, this is center of curvature, this is my focus, this is my principal focus. But how do I explain it? For concave mirror. So what you have to do, what you have to write, define the principal focus of a concave mirror. So principal focus of a concave mirror is the point, it is a point on which all the rays coming parallel, make sure you are paying attention to the word parallel, coming parallel to the principal axis converge. Okay, so this is the definition, but remember bacha, this is the definition for concave mirror, because we know all the rays, they converge in concave mirror, because concave mirror is also called what? It is also called converging mirror, right? But what if I change the question to diverging mirror? What if I ask you to define the principal focus of a convex mirror? What will be that? Hi Teja. All the light rays coming parallel to the principal axis after reflection pass from a point on principal axis called principal focus. Very good, Devesh. Very good. So proud of you. Hi, my name is Aditi Teja. Okay, very easy. It always makes virtual, erect and diminished image. Which question are you answering to? Ishant, which question are you answering to? Okay, done. I asked you, define the principal focus of a convex mirror. So instead of writing the point where all the rays coming parallel to principal axis converge, you will write it appears to converge. For convex mirror, you will have to change just one word, convex mirror. The principal focus is what? On a point on principal axis on which all the rays coming parallel to principal axis appears to converge. Appears to converge. Done. That's the difference. Okay. Ma'am, concave mirror is called converging mirror and convex mirror is diverging mirror, and concave lens is diverging and convex lens is converging. Yes, yes. Very good. Malish. Okay. Yes. Now moving on to next NCERT question. Okay. This is again this, but see, we will do the advanced levels and we'll do so much advanced levels, but we have to build it through it. Okay. You'll go one step by one step, right? You don't want to directly jump to the end of the step, right? You might fall. Done. So we will do the basic questions first, understand the chronology, and then go to advanced questions. Done. Okay. Now, answer me this question. The radius of curvature of a spherical mirror is 20 centimeter. We have radius of curvature equals to 20 centimeters. What is the focal length? Okay, this is a silly question. I get you. Okay, all the light rays coming parallel to principal axis after reflection appear to meet at a point on principal axis called principal focus. Very good, Devesh. Good. Okay, so these are just NCERT questions. So today we are doing NCERT questions, so we'll do all the NCERT questions. Okay, no worries. Yes, so beta, focal length is what? It is 2 times of the radius is equal to 2 times of focal length, right? Now focal length is what? Radius divided by 2. Radius is given as what? 20. 20 by 2 will be your 10. What is the, if it is a concave mirror, if I say it is a concave mirror, then what is the sign of focal length? What is the sign of focal length for concave mirror? Then the answer will be what? Plus 10 centimeter, minus 10 centimeter. Minus 10 centimeter. Great, Malesh. Good. Yes, Teja, I saw your answer. Okay, good. Now let's move on to the next question. Everyone understood till here all the sign conventions, the sign of focal length of concave mirror, convex mirror. Okay, Ishika. Okay, your name is Ishika. I get it. Then let's move on. Yes, it will be 10 centimeter. I just asked if it is a concave mirror, then will the sign be positive? Will it be plus 10 centimeter or will it be minus 10 centimeter? Concave plus 10 centimeter or minus 10 centimeter? That will be, see, we remember for convex, this x, we related this x to 2, we rotated this x and that is plus, but here we have concave, so this is negative. So focal length will be negative 10 centimeter if the mirror is concave. Okay. Srikar. Okay. Srikar. Okay, great. Okay, let's move on to the next question. Everyone ready? Okay, let me give you a fun MCQ. Okay, now give me the answer to this. It's a little bit advanced, but nothing that we didn't study. Okay. Okay, right. Now listen carefully, everyone. Back to the board. A student observed the reflection of light from different types of spherical mirror and made the following statements. He said a concave mirror can form a magnified and real image of an object. Okay. Then he said a convex mirror can only form a virtual image of an object. The magnification produced by concave mirror can be negative. Is it true? Is this true or not? Let me know, everyone. Which points are true, which points are false? Fast. It's taking you a lot of time. Okay, let's look at what we are dealing with. Okay, see beta, first move on to concave mirror. It says that concave mirror can form a magnified and real image. Now I know, as soon as I hear concave mirror, I know that it has 6 cases. Okay, in 6 cases, the first 5 cases are real image. Okay, so this part is correct. Magnified, of course, it forms all sizes of image. So A is correct. First part is correct. Okay, we have the answers as A, option A, C. We have pakka C, maybe C. Okay, we have A. Okay, let's see. It's a tie between A and C. Okay, one more. C is Devesh is also saying C. Okay, let's see. Now, convex mirror can only form virtual image. That is true. Ma'am, convex mirror always forms virtual image. So, second part is also true. Second point is also true. And the magnification produced by a concave mirror can be negative. Magnification is negative when what? When it's a real and inverted image. Magnification is negative for real and inverted image. Magnification is positive for virtual and erect image. Remember this, keep this in your mind, write it down. Okay, write this down. Now here concave mirror forms real and inverted, so it has magnification negative. So third is also true, and we have the final answer as what? The final answer, bacha, is C. C is your answer. So whoever said C, a huge clapping for you. Okay, don't do that. Okay, Srikar is saying Ishika vote goes to C. Okay, great. Whoever said C, Teja, Ishika, Devesh, everyone, great. Done? Okay, understood this one. Let's move on to the next point. Let's move on to the next question. Okay, next question I have for you guys is this one. Okay, let me know this one, and then we'll move on to some tough numericals. Okay, and it requires a lots of calculation. So maybe get a copy and pen. Okay, get a copy and pen because it will require a lots of calculation. Then, how is your summer vacations going, everyone? You enjoying, you are studying, you are some of the people who are actually getting, like, sitting in the live sessions at 5 p.m. in a summer vacation. That's crazy, bro. Okay, everybody said C. Done. We'll final with that. Now, the next question. Name a mirror that can give an erect and enlarged image of an object. Teja is saying a concave mirror can give erect and enlargement of an object. Are? Why did you delete that? You'll only give the access to for like 2 seconds. Hai Teja. Okay. Now, let me know which mirror is the one that can form an erect image and enlarged image. Okay. How will we think? Case 6 between pole and focus. Very good. Ishika, was it right? Okay. Now, you focus on which mirror is it, not on Ishika. It's my advice to you. Okay, we have 2 mirrors, concave mirror and convex mirror. Ma'am, convex mirror always forms erect image, but it is always diminished. It is always small, right? So, convex mirror is out of the picture in the first go. So, what is left? That is concave mirror. And in concave mirror, the first 5 cases are what? They are real and inverted. So the 6th case is left. It forms virtual and erect, and we see it's a very large image on the other side of my mirror, right? This is something like this. It's made something like this, so it's something like this, right? So this is a large image, so it is enlarged. Done. Done everyone. Okay, a concave mirror can give an erect and enlargement of an object when the object is placed between pole and focus of the mirror. Very good. Okay, understood everyone? These are some of the basic points that you had to get clear before we move on to some of the hard questions. Okay? Okay. We'll do some questions and after that we'll go to the refractive index. Okay, one more question for all of you. Why do we prefer a convex mirror as a rear view mirror in vehicles? Why do we prefer a convex mirror as a rear view mirror in vehicles? Yes, what's the question? Should I ask the question? Are you giving the question? What are you saying? Okay, why do we prefer convex mirror as a rear view mirror? That's a nice answer. That's a nice answer. Good. You should write that in your board's examination actually. Okay, now bacha, see, one very good quality of convex mirror is what? Convex mirror, convex mirror, yes. So for one very good quality is it forms virtual and erect, and it always forms diminished image, right? Now you tell me, there you are sitting in a car. Okay, you are sitting in a car, this is a very bad car, but whatever, and there is this mirror and you are sitting and you're driving, and behind there comes a very big truck, right? A very big truck, and it's approaching you, and you see the truck is upright, right? It's inverse. It's an inverted image. Will that work for you? Or imagine a ulta truck coming towards you. No, it won't, right? So concave mirror is out of the picture. We don't use concave mirror because it gives inverted image. And in the case it gives erect image, that's a large image. Now if you are seeing a very large, just the headlight of the truck coming behind you in your mirror, will it be possible to estimate how far is the truck, right? So what we do, we use convex mirror because it gives a virtual and direct image. That's the one very important point. And it gives a diminished image, which eventually gives us the wider view of the road behind us, of the road or the vehicles coming behind us, and that is what we want, to look clearly what is behind us, right? Okay, because it's give a wider view. Ishika, great. Okay, Teja, you should leave now, or you should stop doing this, or I'll get you blocked. Okay, just focus on the study if you want, or you can leave the class. Done? Okay, let's move on to the next question. Everyone ready for the next question? Next question, what is this question? This is also numerical. Okay, let's do this one first. Now, not this one. Let's do which one first? I got one question for you guys. Okay, whatever. Let's do this question first. Find the focal length. Okay. Find the focal length of a convex mirror whose radius of curvature is 32 centimeter. Now, this is important. Why? Because of the sign conventions. Okay, it's a very simple question. Nothing to be bothered about it. But okay, focus back on the board. Everyone, focus back on the board. Okay, now this question is very important because we have to assign the sign to this focal length, to this radius of curvature. So let's just get it over with. Radius of curvature is what? 32 centimeters, and convex, this x means positive focal length, so it is positive. So focal length is simply r by 2, that is 32 by 2, that is what? 1 and 16 centimeter, that is of positive. Very good, Devesh. Now, finally, let's move on to a little bit harder numerical, that is this for you. And I guess this is an unsolved question from your NCERT. Okay, now read it very carefully. We'll give it proper time. We'll learn how to do the question, how to present the question, how to write the answers, because beta, in physics, numerical is half done when it's presented right. Okay, so I have a rule, always we write as we read. This is the one sentence you have to engrave in your mind, body, soul to understand numericals, to do numericals. Okay, now as you read the question, you write it down what is given and what is the exact syntax of how to write this question. See, first write what is given. Okay, now what is given? A convex mirror. So firstly we'll go very slow. Okay, so don't put between don't message in between that fast next question. Okay, we have an answer from Teja. Everyone note it down and see if he's correct or not, because he definitely copied it from somewhere. You even forgot to like arrange it. Okay, whatever. Now a convex mirror. So what is given? A convex mirror is given, and as soon as you write what mirror is given, you are also going to write it down inside the bracket that its focal length is from x, it is positive. So focal length is what, beta? It is positive for convex mirror. We don't know the answer, we don't know the value of focal length, doesn't matter. Right now, the first thing, whenever you see a mirror mentioned or a lens mentioned in the question, the first thing you are going to do, write down the sign of focal length. Okay. Used for rear view on an automobile, has a radius of curvature of 3 meter. So we are given with the radius of curvature as 3 meters. Now remember, convex mirror focal length positive. So radius of curvature is also positive. Done. If a bus is located at 5 meter from this mirror, now remember that this bus is our object. This bus is our object. So object is what? U, and beta, sign of object, distance of object is always negative, right? It is always negative. If a bus is located at 5 meter from this mirror, so this is minus 5 meters. Understood? Find the position, nature and size of this image. Now what we have to find? We have to find what we have to find. We have to find the position of image. That means V, right? Let me write it with some other. So we have to find V, and we have to find nature and size. Nature and size of the image is what? It is defined by height of image, h of I, height of image. Understood? Till here everything is clear? Everything is clear? If anyone has the answer, do let me know. And with that, maybe let me know how did you got the answer. Okay, now this is what is given and this is what we have to find. Now moving on to the solution. See beta, we have radius. That means I can easily from radius I can get the focal length, that is r by 2, that is your 3 by 2 centimeter or meter. Okay, make sure you remember the units. Don't do that in the question it's mentioned meter and in the answer you are writing centimeter. Okay, we have so many answers. The image formed by the convex rear view mirror is virtual rectangle image located at 1.15 meter behind the mirror. Okay, we have r plus 3, u minus 5, v 0.23. Height of image is equals to plus 0.23. Okay. Yes, Teja, ask your doubt. V is 1.5, not 0.23. Okay, we have two answers. Let's see if Ishika is correct or Malish is correct. I forgot your name, Malish. Can you let me know again? How poison is determined? What are you trying to write? Do you write anything in place of poison? Okay, now in the solutions, now we have U, we have focal length. From mirror formula we can easily find V, right? Everything is in your solution. Now solution is by using, how do you have to write? See very carefully. This is where you have to learn presentation skills, bacha. These are more important. Okay, by using mirror formula, we have 1 by F equals to 1 by V plus 1 by U. Now 1 by F is given as basically it's 1.5, right? So we'll write 3 by 2. Okay, so 1 by 3 by 2 equals to 1 by v we have to find, plus u is given as what? U is given as -5. So this is -5. Understood? If I reverse this, this will be 2 by 3 equals to 1 by v minus 1 by 5. Understood? We will take this 5 here. 1 by v equals to 2 by 3 plus 1 by 5. See, you can take 1.5 here, but it'll just make your calculation a little bit harder. That's it. Okay, if you do it by 3 by 2 or 2 by 3, it will be easy. Now take the LCM of this. The LCM of 3 and 5, it's simply 15. 3 into 5 will be 15. So 2 into 5 will be what? 10 plus 5 into 3, that is 3. That is your 13 by 15. Done? Now this is your what? This is your 1 by v. So v will be what? 15 by 13, and this is in meters, remember. Okay? This is in meters. Done? And if you cut this, you will get the same answer, 1.15 meters. So v equals to 1.15 meters. Now see one thing. What our mirror was what? It was convex mirror. Now you remember how to check if your answer is correct or not. This is my convex mirror, and the image I know is always formed on right hand side, right? The image is always formed on right hand side for convex mirror. That means it is of positive sign. So is my v of positive sign? Yes ma'am, it is of positive sign. So we happily concluded our first answer, that is your position of image. Done? Now what is the nature of image? Simply, you know it's a convex mirror. So you know that for convex mirror, the nature of image will simply be virtual and erect. And it is diminished. So remember, u is what? -5 meters. V is 1.15. So it is closer to the mirror, right? Now we know that, so it is already diminished, right? It is also diminished. But what we have to find? We have to find height of image. Now height of object, is it given? Is it given, the height of object? No, it's not given. So how will we do that? How will we find the height of image? How will we find the height of image, everyone? Okay. V is 1.15. Okay, everyone. How do we find the height of image? First, you let me know that. Okay, can I give that as a homework to you? Shall I give that as a homework to you, the height of image? Magnification formula, obviously, but I am asking that you have this magnification formula, right? That is -v by u, and that is equals to height of image by height of object. But I don't have height of object, right? Here, a convex mirror used for rear view of an automobile has a radius of curvature 3 meter. If a bus is located at 5 meter from the mirror, find the position, nature and size of the image. So the answer you are giving, is it actually height of image or just the comparison of height of image with height of object? Let me know first. Okay, look at this very carefully because it might confuse you later. Okay, so here if they have asked the height of image, so you can't write height of image equals to plus 0.23, right? So look carefully. Now minus v by u. Let's do it in a careful manner. Okay, don't use 1.15, that's hard for calculation. Let's use 13 by 15. Okay, so 1 by v or v is 15 by 13, right? So v bacha is 15 by 13. So magnification is what? Minus 15 divided by 13, and u was what? Minus 5, right? Equals to height of image by height of object. So if you just cancel it, this is 3. So this will be minus minus also cancels. 3 by 13 equals to height of image by height of object. Understood? Yes, yes, we will find by v by u only. That I understood, bacha. But the way you are writing the answers is not correct. Okay? The way you all are writing the answers is not correct. Done. So see, the answer is same. The answer is 0.23, but this is not height of image. This is height of image divided by height of object. This is magnification. Done. So when you write height of image, so you will write that height of image is 0.23 times the height of object. Or if you have to write just 0.23, then magnification is 0.23. Understood this point? Clear to everyone? Understood this point? Clear to everyone? The way you are writing that height of image is equal to 0.23, that's wrong. That's wrong. It's actually 0.23 of the height of object. That means if my height of object is given as 2 centimeter, then this height of image changes, right? This height of image becomes 0.23 of 2 centimeter. So it becomes 0.46. Right? So now height of image changed. Height of image changed. Correct. Based on the height of object. So you have to write height of object 0.23 into height of object. Understood everyone? What? Was it too deep? Was it much hard? Okay, this is the very clear thing you have to remember, because they have not given us anywhere height of object. Done. So you have to write height of image equals to 0.23 of height of object, not just 0.23. Done. Everyone understood my point? What am I trying to say? Everyone understood what I'm trying to say? Or is there any doubt? So we'll move on to the next. It was dead easy. Okay. Okay. Okay, the numerical was easy, I understand, but the way you write it can get your marks cut. So make sure you don't do that. Okay, okay, Ishant, great. Okay, next let's move on to the question. This one. Okay. Give me the answer to this question. A concave mirror. So what we do? We write given in the very first glance, and we write what is given, that is a concave mirror is given. A concave mirror is given, and the focal length of concave mirror we write this focal length as soon as we see the mirror. So that is negative. Concave mirror has focal length negative. Okay, okay, okay. Done. Now this concave mirror is focal length is negative. Now bacha, read the question. Produces 3 times magnified enlarged real image of an object placed at 10 centimeter in front of it. Let's break this. Okay, let's break this question. The mirror produces 3 times magnified real image. That means magnification is given, right? And magnification is given as 3. But one thing you need to remember, it's written that it's a real image, and in real image magnification is always negative. Why? Because of the real image. Magnification is negative. See, this is where you will lag. You have to put this -3. If you take +3, your whole answer will be wrong. Okay? What, ma'am, can you tell session is? When? So that I attend. It's from 5 p.m. Yes, Ishika. Okay. So Ishika has given the answer as V -30. Okay, let's see if you are correct or not. Now, of an object placed at 10 centimeter, that means U is 10 centimeter and U is always negative. Now I have magnification U. Where is the image located? By just using magnification formula, we have to find, see, you write to find, and that is what? Where is the image located? We have to find V, right? So let's move on to the solution. This one is a little easy, right? We'll just use the magnification. The only trick was this negative sign in this whole question. And these are the small tricks that you need to remember, things you need to remember. Ma'am, you're reading the comments, but you're not reading mine. What you're not? I read your answer. Don't worry. Okay. Okay. Ma'am, image distance is -30. Image is real and on front of the image. On front of image. What is on front of image means, Ishika? Okay. Now magnification for a mirror is what? -V by U. Right? Now magnification is given as -3. Remember, it is -V by U. Magnification is given as -3. This minus sign is important. And we have to find V, and U is given as -10. So -V divided by -10. Understood? Now this minus cancels. This multiplies here. So V equals to -3 into 10. So V, bacha, comes out to be -30 centimeter. Done. Okay, let's have challenge for the next question. First, I gave the answer. Okay. Okay, all of you gave the answer. Very good. Now, understood? You understood how we got the negative sign in magnification. Okay. Now, last question of the day, everyone. It's a little bit hard, so make sure you read it very carefully. Okay. Now, an object 4 centimeter in size. So what we'll do? We'll write the given conditions. We'll write the given conditions, and those are what? An object 4 centimeter in size. So height of object is given, that is 4 centimeter. And object is always on upper side of principal axis, so it is positive, right? Hi MPPS. Okay. You, whoever wants to have a challenge, this is your question, give the answer and we'll see who gave it first. Okay, I'll write the name here of whoever gave the answer first. Now, it is placed at 25 centimeter in front of a concave mirror. Lots of information. It's placed at 25 centimeter. That means U is 25 centimeter and it is always negative. Right? Now, in front of a concave mirror. So, this is what? This is concave mirror. Done? Now, what we do as soon as we write the mirror? We write the sign of its focal length. The focal length of concave mirror is what? It is negative. Okay. Ishika is already giving the answers. Not the front of image, front of mirror. Yes, I understood. Okay, image formed is inverted and enlarged. Okay, that's one answer. Teja has given one answer, that is -6 centimeter. So for now, Teja is in the lead. Okay, just letting you know. Now, of focal length 15 centimeter. Now see, the sign of focal length is not given. You have to use your own brain. Since it is a concave mirror, focal length is negative, right? At what distance from a mirror should a screen be placed in order to obtain a sharp image? So what we have to find? We simply have to find where the image is formed. That means image distance that we have to find. Find the nature and size of the image. Okay, let's see your answers. See, Ishika, my answer. Okay, -6 centimeter. The image is formed 30 centimeter in front of concave mirror and is real and inverted and 3 times larger than the object. Okay, -6 centimeter. Your English is awesome. Thank you, Devraj. Okay, great. Let's see who won. Okay, come on, let's do the solution. Now for solution, we will use white pen. Okay, solution is what? Now simply we have to find V. So we'll have to use mirror formula, right? We will use mirror formula. Done. Now what is the mirror formula? 1 by F equals to, correct? Let me write it here. 1 by F equals to 1 by V plus 1 by U. Now what is the focal length? -15. 1 by -15. 1 by V. V we have to find and U is -25. 1 by V, that is we have to find, plus 1 by -25. That is it. That is done. Okay. Formed is real and enlarged and height of object is +4 centimeter, U -15. Okay, we have the answer by Ishika. Yes, I've checked. Okay, Ishika's answer is correct or not? Let's see. Ishika's answer is V equals to -37.5 centimeter and height of image is 6 centimeter. -6 centimeter. -6 centimeter. Okay. But Teja gave the answer. Yes, Teja gave the answer first. But Teja gave the answer of height of image, not the V. That I remember. Ladki ka chakkar babu bhaiya. Okay, hello Sumi. Know me, sincere student. Okay. Now, let's do the calculation quickly. -1 by 15. This is minus. It comes here. It becomes plus. So if you take the LCM, what will be the LCM? Simply 75. 15 5s are 75 minus 5. 25 3s are 75 plus 3. 1 by V. Now this becomes what? -2 divided by 75, that is 1 by V, and V becomes -75 divided by 2, where V answer is -37.5. If you cut this, this will be what? 3s are 6, 7 14.5. So V is -37.5. Done. Now, this answer was given by whom first? By Ishika or Malesh? I forgot to look. Okay, you tell me who gave the answer first. So, this is the answer for image, right? Then, beta, we have one more thing where they asked us what? They asked us nature and size of the image. So, we found V, right? We also have to find nature and height of image. Now, what is the image nature? Let's find it through magnification. Okay. Now, you see height of object is given. Okay. Magnification beta simply is -V by U equals to height of image by height of object. This we have to find. This was given, this we found, and this we are given, right? So let's see. Now -V, I will not use this because it's very hard to calculate. I will use 75 by 2, right? So that is minus of, see, there was already a minus here and a minus with V value, -75 by 2. This is -75 by 2, right? So minus of -75 by 2 divided by U was what? U was 25 centimeter. U was 25 centimeter, always negative. Now height of image, we have to find. Height of object is given as 4 centimeter, always positive, 4 centimeter. Now simply just cut these signs. Minus 75 by 2 into 25 equals to height of image divided by 4. So 25, 3s are 75. So this is what? Minus 3, this cross multiplies here, 4 divided by 2, height of image, this cancels out at 2, so height of image is minus 6 centimeters. This is your answer, I guess first given by Ishika. Okay, yes, by Ishika. So we will give the reward to Ishika. I don't know how to make a crown, so maybe this is your crown. Okay. Yes. Now, regarding the nature of image. So, beta, see, the nature of image can be directly calculated from magnification. Magnification, see, magnification is, even if here you see height of image is minus 6. Minus 6 means below the principal axis. Below the principal axis means real and inverted. Simple. But if you still have to calculate it, height of image by height of object, height of image is minus of minus 6 divided by 4. So this cancels out. We get 3 by 2. Done? We get, oh, this minuses should not be here. Yes, that's what I was confused about. Okay, so this is minus 6 minus 3 by 2. So magnification is negative. Magnification is negative. That means the image is real and inverted. Okay, done everyone. Okay. Oh, you're cheating. Yes, I would have, Srikar, I will, but we are done for today's question. You join the next live and I'll definitely bring more challenges for you. Okay, every Wednesday I am coming live for science at 5 p.m. Okay, and we'll do questions, we'll understand the concepts. If you have any doubt, you can ask me. Done. And we did so many great numericals today as well. Okay. Here there is no value for real students like me. Arey bhaiya, what is this emotional breakdown? Okay, everyone, that is it for the live today. I'll meet you tomorrow. The live will be for 9th class. Okay, we are doing the first chapter of chemistry. So if you know anyone, you have siblings, go tell them to join the live session. We'll do all the questions like this. Okay, and I'll meet you next Wednesday. Make sure to join. Okay. Okay, yes, Ishika, you deserve it. Okay, bye. Okay, Srikar. Okay, I'll give you this point this time, okay, but next Wednesday we'll have a full-on challenge and I'll keep the watch who's giving the answer first. Okay, bye, tata.